In this exercise, we're going to use queues to perform a type of sort called a radix sort. This is a fairly lengthy exercise, so I've already written some of the code in advance. In fact, I've written all of main already to save us a little bit of time. The way radix sort works is that we create a set of queues, in fact, an array of queues. And the queues we're going to hold numbers 0 through 9, 10 through 19, 20 through 29, and so on and so forth. And then what we're going to do is we're going to take the numbers in the array that we're trying to sort and distribute them among the queues based on their values. And then once all the numbers have been distributed, then we're simply going to go back and collect them into one array. And by taking the queues in order from the 0 through 9s through the 10 through 19s and so on, then we'll have our numbers in sorted order. So that's what we're doing in main. We're creating an array of queues. Then we initialize that array, or each queue in the array. Then we create an array called numbers. Then we assign it some random values. Then we display it to see what it looks like unsorted. Then we begin our series of distributions. A set of distribute and collect for getting the numbers in ones place. Then we display. And then another set of distribute and collect for the tens place. And then we display the final result. So let's go on now and define our methods. The first method is distribute. It takes an array, a linked list array, or array of linked lists, and then the digit type ones or tens that we're trying to distribute. So then we write a loop. And we check the digit type. And if it's equal to ones, then we take the current element mod 10 of the array. That's going to be the queue that the number is going to be stored in. And we add that number to the queue using add last. If we're not doing ones, then we're doing tens. So here we divide by 10 and then add that number to the appropriate queue. Close the else, close the for, and then close the method. And that's how we distribute. Next, we have to collect. The parameters are the queue array and our numbers, the numbers that are in the regular array. So we declare a variable I and set it to 0. And we have a for loop. It looks at each queue in order. And as long as it's not empty, in the correct position of the array, add that number to the array by removing it from the appropriate queue. And notice that because queues or linked lists store elements as object, we have to cast to integer right here to get that into the right format. So that's how we collect. And then finally, last but not least, our display method, which I probably should have copied from somewhere else, but I didn't, so I'll write it out here real quick. We've seen this before. Here I'm just trying to display the numbers in lines of 10. I won't spend a lot of time describing how this works so I can get it typed in. Just have to make sure I don't type too fast. So that prints a blank line if we've had 10 items printed. And then we print a blank line at the very end. And we're done. So again, here's the main program. Most of the code, or at least half of the code, is just in getting things set up. Then to perform the sort, we only need 4 method calls, actually. Of course, those method calls themselves have many more lines of code. So let's save the file. Compile. Cross our fingers that there aren't any errors. Only one typo. Not too bad for a program of this size. I know exactly what the problem is. Let's find it. Our array type is called digits, not digit. So there we go. We'll save. Come back, clear the screen, compile again. Here's our unsorted array. Here's through the first pass, and the last pass is the array sorted. Now later in the course, we're going to talk more about sorting algorithms, and we're going to look at some that are much more efficient than this. But I wanted to demonstrate a use for queues besides simulations, and radix sorting is certainly one application for queues. But with that, we're ready to move on to the last exercise for the chapter, where we're going to work with binary trees.